Welcome to Lesson 8, Arrays, Topic 2. In this video, we're going to see how we can represent information which we can then use in conjunction with the Circuit Playground Express. So let's get to it. So I've already set up a couple examples and it will be our starting point. So for this first example, what I've done is I've created a bunch of positions that represent neopixels that I wish to light up. Now, again, we've lit up various neopixels using the for loop, but the problem with that is that it's very linear in the sense that you'll start with 0 and then kind of continue on to the very last neopixel. But what if we wanted a slightly more sophisticated effect? So you can see here the positions that I'm representing in my array is position 0, and then I'm going straight over to the other one on the other side. So 0, 9, come back to the left side for 1, go back to the right side for it. So you're going to see like an alternating neopixel light show here. Again, we couldn't really get that with just a for loop. Again, technically you could have if you got a little more creative with what you did in the for loop. But this kind of attacks the problem straight on in that these are specifically the positions we want to light up and in this particular order. So as you learned in the previous video, when you work with arrays, you'll typically also use a for loop. So let's just verify. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10. So I put 10 here. Again, this has nothing to do with the fact that it's the neopixels positions. This is 10 because I got 10 elements in my array. And we want to go through each element. So we're going to do an I++. So let's do a circuit playground dot set pixel color. And if you recall, the first thing that set pixel color needs is a position. Now, if I put the variable I here, it's simply going to be 0, 1, 2, 3, all the way through. But that's not what I want. I want to use the positions that are stored in this array. So if you recall, our usage of arrays, so we're going to put the array name first, followed by the brackets. And in order for us to access each of these positions, this is where the variable I comes in. I'm going to put the variable I here so that I access position 0. Well, position 0 is going to give me the very first value, which just happens to be 0. When the loop goes through, it will now increase I by 1, making I 1, and then this becomes position 1. Now, position 1 will retrieve us the 9. And at this point, we're going to keep it simple. Let's just color it. Let's do magenta. And let's actually throw that circuit clear pixel inside the for loop. And that means we could take it out of here. And let's also create a small delay so we could kind of enjoy the light show as it goes through. And, let's do it as a 50. That way it's a little quicker. All right, let's run it and see what happens. First, I'm going to set up the camera. So that might be a little bit too fast to kind of see the alternating side. So let me put it back to 100. And there you go. I think at this point you see more of that alternator where it goes from one side to the other, to the other, to the other. Again, this was made relatively easy by using an array that allowed us to specify the positions. Now, if you kind of think about it, I mean, there's no limit to what you can do here. If there's a very exact patterns of lights that you want to display, you can use that. You can represent that using an array. So here's one example of representing information in an array and then using it with the Circuit Playground Express specifically to light up the neopixels. Let's go into another example. So In this example, what I've represented just happens to be in coincidence in an array called position. I've represented the actual values that get used with the read cap in order to gain access to each of the capacitive touchpads. And again, this happens to be a very common thing to do, to try to access all the capacitive touchpads to see if maybe someone has pressed any of them. So what I'm going to do here inside the loop is, again, just like we've done before, I'm going to create a for loop. I'm going to start it off at 0. I'm going to go I less than, let's see how many numbers we have here, 3, 6, 7. And I'm going to do an I plus plus, so we can go through each element in the array. And now I'm simply going to do an if statement where it says circuit playground dot read cap. Now, if you recall, read cap needs a value for the position that you're going to read, which capacitive touchpad. And normally we would put a number here like 0, 1, 2, 3, 6, 9, or 10. So obviously we can't use the variable I here. It's not going to work. Again, you'll be testing positions that don't exist. But let's go back to what we had said in the previous example. The information we want to get access to are these numbers. And these numbers are stored in a variable called position, in an array called position. So I'm going to start off with the array name, POS. I'm going to put the brackets. And just like you saw in the last one, I'm simply going to use that loop variable in the square brackets so I can access each of these elements. So this is going to allow us to do a recap of 0, recap of 1, recap of 2, a recap of 3, a recap of 6. Again, remember, the I value is simply increasing from 0 to 6. So it's going to do 0, 1, 2, 3, 4, 5, 6, which then allows us to grab these positions. Again, with practice, you'll learn to disassociate, associate, depending on how you want to think about it, the purpose of the value of I in the loop variable in conjunction with the array. All right, so let's do this. So if any position is, let's say, over 400, hopefully that should be good enough, then we're going to do I think I have it. Let's do a color all. I added this extra function just to make my life easy. And for this one, let's do yellow, which is red and green. So we'll do 255 and 0. And let's give this a try. So again, by representing the positions as an array, what did I do here? Oh, so it would be color. Oh, wow. Okay, so I realized I actually used another function. So, I'll just fix that up. As circuit playground dot set pixel color of POS, and this would be RGB. Sorry about that. I should do it. Okay, so again, the whole purpose of this is that we wanted to have a very convenient way of testing all the capacitive touchpads. And then representing the positions as an array, and then using a for loop to go through it, avoid us having to actually create, 6 different if statements that specifically checked each one. Again, one of the strengths of using an array along with a for loop, there's something that we can process for each of those pieces of information in the array. All right, so let's actually test this out, and hopefully it all works out. And if I touch any position now, you should see the lights turn on. They're going to flicker a little bit. That has to do with the inconsistency a little bit of the recapacitive touchpad in terms of being a consistent value. It also has to do with the idea that I put a clear pixel in there. So let's try a different one. So we get this one. Let's try these up. Oops, use my other hand. These up here. So you can see I'm able to kind of test if I touch any of them. So again, if we hadn't used an array, we would have had to use 6 different if statements, and duplicate that code. Again, that's not something you want to do in programming. All right, so for our last example of using arrays with the Circuit Playground Express, what I'm showing you here is that we've created a couple of variables to represent notes and their frequencies. And then I've created two arrays, one that actually stores the notes for Jingle Bells and another one that stores the durations for each of those notes. And I want you to see what's actually being stored here. The strength of using variables, that this becomes very readable. This is something you can actually give to like a musician, and they'll be able to say, okay, I can hear the music. Because again, musicians can read notes, so they can see, E in the fourth octave. So we got E, 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 G, C, D, E. And then they can associate the numbers down here with that tempo for each, or the duration for each of those notes. So let's go to actually play this, but I want to do this a little bit differently, in that I want to create a function called Jingle Bells, which will then access that information. So just as we've done in the last two examples, let's create our array, I equals 0, I less than, I believe there's 11 items in here, and we'll do an I plus plus, so we can go through each note and each duration. And honestly, the only thing we have to do now is do a Circuit Playground dot playtone. Now, if you recall, playtone needs two pieces of information. The first thing it needs are the notes, and our notes are being stored in this array. So I'm going to do this. I'm going to copy this over here. And as you've seen in the previous two examples, we got the array, and because we want to access each note, I'm going to use that loop variable that starts at 0 and continues up till 10 in order to access each of these positions that start at 0 and end up at 10. All right, so that's the notes. The next thing we need is a time in milliseconds, a duration. So I'm going to do the same thing for the Jingle Bells duration. I'm going to put that here. And also, similar to what we just did, I'm going to use the I variable. So what you're seeing here is the use of two arrays with associated information. These are called parallel arrays because each position matches the information in another position. And I think that's pretty much it. So let's call Jingle Bells inside of our main function, or inside of our loop function, Jingle Bells. And then let's offer a small delay of, let's say 2 seconds in between each iteration of Jingle Bells. All right, so let's give it a run. And there won't be much to look at, but I'm going to put the camera on anyway. Okay, so you can kind of hear it's a little slow on the tempo. And I'm going to try to catch it there. And if you recall, there's really no way of turning off the speaker. You got to just disconnect it. So we noticed that the tempo was a little on the slow side. So remember, an array is just information, which means we can do stuff to the information. So instead of manually reducing the durations in order to increase the tempo of the song, what I can do is leave the values as they are. When I retrieve the values from the array, I could simply divide it by 2 before I actually use it in conjunction with the playtone. Yeah, so I'm going to reconnect this and try to muffle the sound for you while I upload. All right, there, that's good enough. Again, not much to watch, but I'm going to hold it there anyway. So I would say that sounds a lot better than what I did before. Okay, that's enough for me. So what we saw in this last example is the fact that we can use the information from the array, adjust it before we actually use it in conjunction with the Circuit Playground Express. So let's go back to our presentation and let's review what we've done. So in this video, lesson 8, topic 2, we saw how we could represent information that could then be used with Circuit Playground Express. Specifically, we explored using arrays to store positions for neopixels to get turned on. We use an array to store the positions of the capacitive touchpads so we can check to see all of them through a loop, which saved us a lot of time. We didn't have to write 6 different if statements. We simply wrote one if statement going through each of the positions that were stored in the array. In this last example, we saw how we could use an array to store the notes, the frequencies of a song, as well as the durations in a parallel array, and then use that for loop to go through both arrays and actually play the song Jingle Bells. So arrays are very powerful. It's pretty much left up to you to envision some way that you can store lots of information and then use that information in conjunction with your Circuit Playground Express. Enjoy.